This is a statistical hypothesis testing tutorial using SciPy. And this tutorial, I will explore how to perform common hypothesis tests using the SciPy.stats submodule. I will cover t-tests, ANOVA or analysis of variance, and chi-square tests. I will also explain the concepts behind these tests and provide step-by-step implementation examples. Okay, let's get started. First, you have to import necessary libraries. The necessary libraries in this tutorial are NumPy as NP, and I also import the stats module from SciPy. Now, I just imported the required libraries. NumPy is used for generating sample data, and the status.scipy contains functions for performing statistical tests. Okay, the next step is generating sample data. In this case, I will use NumPy to generate sample data because so sample data gonna help us to test our statistical hypothesis. So for the purpose of this tutorial, let's generate some sample data for our tests, and I will use NumPy to create arrays of sample observation. And in this case, I will create three groups of data, random data, which is normally distributed random data. Group one, and random normal. And I just use log is 10. Size is 30. I just want to copy this and create three different groups of data. I just modify this 2, 3, and I also modify the mean. That's 12, and the other the size and the scales are equivalent. Okay, here I just generated sample data for my tests using NumPy, and I generate three different groups of randomly distributed data: group 1, group 2, and group 3. So this distribution is with different means. Each distribution, groups of distribution data has different groups. The first group is 10. The mean of the first group is 10. The mean of the second group is 12, and the third is 15. And the standard deviation is it is 2 for all distributions of data. So now I have just generated the required groups of data, randomly distributed data, and the next I will show you how to test t-tests using stats.scipy. Okay. So now let's test t-test. Basically, t-test is used to compare the means of two independent groups. For example, in our randomly generated data, we have three independent groups of data, and I just gonna compare the two independent groups of data to test the t-tests of this statistical hypothesis testing. Okay, let's do it. T-statistic, take and p-value. Then I just use this t-test _ind. This is the function from stats.scipy. Then I just pass group 1 and group 2. This is going to compare the means of the two independent groups of data. And let's see the output of this. Okay. Here is the t-statistics of the two groups of data, and the p-values are also this one. Now let's compare either the hypothesis is rejected or paired. Reject to the null hypothesis, which means the means are significant. So the means are significantly different by comparing. Let's define significance levels of p-value. Yeah, the p-value is basically 0.05. This is the minimum, which means the significance level of the p-value. If the p-value is not greater than this alpha, if it is less than this, so that is the means are significantly different. Otherwise, the means are not significantly different. So let's do this. If the p-value is less than to the significance difference level, then we can print that reject the null hypothesis. The hypothesis means are significant difference. And else tell to just modify this, tell the null hypothesis, tell to reject the null hypothesis. Means are not significantly different. So I can just compare. Actually, it will be less than this significance level, because this is the p-value and it's just reject the null hypothesis. Means are significantly different. So it's just compare. Yeah, reject the null hypothesis. Means are significantly, because the means are under the significance levels of or the threshold values of p-value. So this is a t-test. So you can just perform a t-test. The t-test underscore IND function performance at two samples, group 1 and group 2, two independent samples. So the t-test, it calculates the t-statistics and p-value to test whether the means of group 1 and group 2 are significantly different. So a lower p-value suggests stronger evidence against the null hypothesis. If the p-value is lower than the threshold, which means below the significance level, so it just rejects the null. So the p-value is just suggests a stronger evidence against the null hypothesis. So if the p-value is less than the threshold or the significance level, so alpha, which is that strongly evidence against the null hypothesis, which means that reject the null hypothesis. The means are that the means of the two groups are significantly different. Okay, the next is ANOVA or an analysis of variance. Okay, next I will show you ANOVA or analysis of variance. ANOVA is ANOVA, which means analysis of variance. ANOVA is basically used to compare the means of multiple groups. If we do have more than two groups, we can use ANOVA, analysis of variance. It helps us to determine if there are many statistically significant differences between the group means. So in this case, I have just generated 3 groups of data. And I want to just compare the statistically significance of the 3 groups of data using ANOVA or analysis of variance. Okay, let's do it. Performing one-way ANOVA. First, let's find F statistics and P value status dot F one way. There is a function F one way, and I just pass group 1, group 2, and group 3. But the t-test cannot perform more than 2 groups of data. So that's why we need to perform using ANOVA. ANOVA can do more than 2 groups of data to compare the means of the groups of data. Okay, now let's print out the statistics. F static. Okay. So the p-value is still it is lower. So I hope that rejects the null hypothesis, which means group means are significantly different. Each group, so the means of each groups are significantly different. So I can do by comparing this is by performing the same okay, I can just copy paste this one and so I hope it rejects the null hypothesis. Means are significantly different. I hope group means, because here I compare 3 groups of randomly distributed data, but in the t-test I just compared only 2 groups of data. So because the p-values is below the threshold or the significance level, so this 0.05, so that rejects the null hypothesis. And okay, now The last step in this tutorial I'm gonna show you is chi-squared. This is another test method. Chi-squared test is used to determine if there is a significant association between categorical variables. Especially this is very useful for determine the associations of significant associations of categorical variables. First, I should creating a contingency table. So I can use NumPy array to create a contingency array, which is 10, 20, and a two-dimensional array, 15, 25. This is the contingency table. Then performing a C-chart squared test. So expected status dot T2 contingency. And I just pass observed. Okay. I can print. First, let's print this. I can copy paste this and T2 statistic and p-value. So I hope in this case the p-value is higher than the threshold, that is 0.05. So it's really fails to reject the null hypothesis. There is no significant association. This contingency table or between categorical variables. So I can just make sure by comparing this, for example, it would fail reject because that is greater than the p-value is greater than the threshold. Yeah, it is better to lower than the alpha or 0.05. That could be a significant difference. For the chi-square test, I create a contingency table named observed. So the chi contingency function computes the chi-squared, chi-statistic or chi-squared, and statistic p-value, degrees of freedom, and also here is DOF is the degrees of freedom and expected frequencies. Here I have calculated 4 different values, but the most important thing here is the chi-statistics and p-value. Especially the p-value is more than enough to just make a conclusion that the data is significantly important or not. Okay. This test determines whether there is a significant association between the categorical variables represented by the table here I created. So, in this case, the p-value is greater than the threshold and it has no significant association. And in this tutorial, you've learned how to use the SciPy.status submodule to perform common hypothesis tests. The t-tests, ANOVA, and chi-squared tests. You've also learned how to interpret the results and make informed decisions about rejecting or failing to reject the null hypothesis based on the p-values and chosen significant label. This knowledge will help you analyze and draw conclusions from data in various contexts. Don't forget to like, share, and subscribe. Thanks for watching.